Welcome back. Hello. Welcome back. Hello.
Those what do you like? This is also for my stuff.
There's more stuff that I have. That's a fridge.
Levi, if it's not the living room, you might have my grip I've been reading for the last 2 days. I had a fun time yesterday on not Wednesday, after school was over. Cause I went to my mom's and I started to play shotgun for a night. I'm addicted to it, okay? I literally spent I woke up at 4, then I tried to go back to sleep.
In the morning?
But I couldn't go back to sleep, so at 5:34, I just went to my Xbox and played it, and I had to get 500 kills with a shovel.
Oh my gosh. You shouldn't be playing that game.
They shoot people with vegetables and stuff. It's funny, you guys beat them to death with a shovel, or a broom, or an oversized popsicle,
Welcome back, guys.
or a mace,
See your Monday, Thursday.
or a bag of nails.
Alright, so all the only day we ever have is a Monday or a Friday.
What else can I also beat them with? Oh, I can also beat them with a mailbox.
Oh my god. But you thought
Maybe she could be like Swiper Souls where he gets hit in the head with a mailbox.
Definitely. Oh, you know, where we're looking at each other, that's like thinking that was you. It was you. I said, it's already Thursday.
You could also hit them with a
It was like
gnome,
Monday.
a gnome on the end of a stick with a sharp hat. You could also hit them with a scythe, a pitchfork.
So we are moving into lesson 12, which is pretty similar to the stuff that we did on Monday. So those of you that were here, if you're at home, we went through, and we were kind of talking about an amusement park ride and someone walking through the bumper cars and things like that. Revisiting that same problem, but now just talking about more students who are walking the bumper cars. We started talking about graphs and how do you tell if someone moves faster or slower, so more things like that. If you follow the link, it's going to take you here. Try to just figure out those 4 problems in your head. Do you remember how to multiply fractions at all?
Kind of.
Anybody?
I forget if you multiply across or diagonal.
Right. So just because this screen you're able to write on, so you can write on it. Try to find those answers just to give everyone time to log in, me to wrap my head around the attendance. But just see if you can remember how to multiply the fractions. Try to do it without a calculator is the trick.
Now it's not easy. Well, Miss Landon, guess what? The bad thing about the game is that it's only $10. But I didn't have to pay for it, my friend gave me it.
I was the king of fractions in primary.
No.
Then you're gonna be good at it now.
Huh? Sometimes I can't understand what Levi says.
No me.
It's not impossible.
Lucky math, RJ, on.
It's actually really, really, really easy. You guys hate fractions.
I hate
I
everything.
get it.
It was so easy.
So fractions make me so much.
Wait, how is my iPad at 89? It was literally just at 99.
You used to say fractions are your friend.
Yes, they make things, I don't say that,
I
but
swear,
they
I'll look
make
away or I
things
turn this
so
off.
much.
You would
Easier.
say that diamonds
goes
are
down.
our best friend.
That might be true.
Miss Landon?
What?
My iPad was at 100 and then it went down to 99 and now it's at 89.
You just did too much work in ELA.
No, I didn't. I just turn it off or shut it off or put it down and look away. It goes down quicker.
Okay, the majority of us are in here now.
James's iPad is just ancient. That's why I kept turning it off.
So Heather initially said she kind of remembers, she doesn't remember if you go multiply diagonally, if you multiply across. Does anybody remember how to multiply fractions? Say, straight across. So if I'm multiplying, number 1 and number 2 are pretty much the same because they're multiplication. We're gonna get into a conversation of division down here. But if we multiply straight across, what's 2 times 1? 2 over 6. So then you would always want to kind of reduce it. Do you remember how to reduce fractions?
Not even a little bit.
Find the common factor. So what can I divide a 2 and a 6 by? Chris?
1.
1, but if we divide by 1, it's not gonna change. So it's true. Two. So 2 divided by 2 gives you 1. 6 divided by 2 gives you 3. So you multiply straight across and then try to see if you can reduce it. Not the end of the world if you can't find how to reduce it. What's wrong?
We didn't even do reducing fractions.
That's okay. Sorry, I didn't know. So 4/3 times 1/4 is gonna be what?
4. 4,
Oh, you're talking about on the top?
no, the next one.
Yeah.
Yeah,
So go straight across, you get a 4 on the top.
the other one, I don't know.
3 times 4. Sydney? 12.
Seriously, that's all you can get out of me. I'm not that smart.
So then try to reduce it. So now you're just thinking, what can a 4 and a 12 divide by?
By 2.
You can divide them both by 2, so if we do that, we get 2/6. But then try to do it a step further, can I divide that
No.
again?
Again.
Yeah,
So okay, one step at a time. You can keep going in bits and pieces like that and divide by 2 all the way down.
no.
You could have noticed that you could also divide 4 and 12 by 4 and jump right there, but it doesn't matter. So now we have to divide. You remember how to divide.
You just, work.
So step 1, if I have a big whole number here, is I can put and make it 4/1, so I have 2 fractions. That would be step 1. But there's a saying that normally goes along with dividing fractions.
What was that?
Anybody remember what it is? So anytime you have a division problem of a fraction, we can change it into a multiplication problem. Same change flip. Did you do that at all last year?
Yeah.
So keep the first number the same. We can change the division problem to multiplication, and then you flip your other fraction. So instead of 1/5, we have 5/1. So we have 4/1 times 5/1. So what's 4 times 5?
20.
20. What's 1 times 1? Just 1. So what's 20/1? 20.
20. That's what I said.
Same change flip. Keep the first fraction the same. So I have 9/6. Change to multiplication. Flip your other fraction. So then what's 9/6 times 2/1? 9 times 2 is 18. 6 times 1 is 6. What's 18/6?
Yeah, I sure hope it does.
I wanted to say that. James, did you say it?
Great. So a big fraction is just a division problem. So just to help you kind of think about. Stop looking at it. What do you do?
You just went, oh boy.
Okay. I heard them. There's only like 6 of you in here. You can hear everything your little mouth lines up in here. Just to help you with your mental math and things like that as we move forward. So doesn't go along too much with what we're doing, but I just wanted to go over that to remind you how to do your fractions. Okay, that's not happening. I'm talking means you're not making noises. Thanks. Okay, I'm gonna switch your slide. Maybe.
Wait, who's that person?
What?
That person that had the calculus thingies, whatever it's called.
It's just a clip from a movie. Okay, so this is what I was saying before where we're going back to the problem that we looked at on Monday. On Monday, we had someone going to the bumper cars.
Excuse the interruption. Will staff rule please report to the main office at this time? Staff rule to the main office. Thank you.
On Monday, we had one student going to the bumper cars. We have his chart down here on the left. We talked about his numbers, how fast he was moving. It took him 40 seconds to walk 50 meters. We found the constant of proportionality, we graphed it. Now on this slide, we just have 2 more people. So we're gonna read A and B and then fill in their charts accordingly. So part A says that Gerald left the ticket booth at the same time as Arnold. He jogged ahead at a steady pace and reached the bumper cars in 30 seconds. Chris, it didn't change your slides? Did anybody else's?
I changed mine.
Okay, good. I was like, please don't tell me I sent wrong links because I don't want to deal with that. So I have that he reached the bumper cars in 30 seconds. So the bumper cars from Monday we're 50 meters away from the starting line. So that means right away, I knew that he took 30 seconds to travel 50 meters. How can I use that information to fill in the rest of the table? If he's walking at a constant pace or a steady pace. Sydney?
50 divided by 30 and what the values you,
Wait, what is that?
multiply.
Exactly. So he's walking at a steady pace, so that means I can use my constant of proportionality. So in a calculator, do 50 divided by 30. Anybody want a calculator?
Yeah.
So this is basically yeah. Yeah, what are we typing it by?
Not times of anything, you're doing 50 divided by 30. Yep, because I have 50 meters in 30 seconds. So what's Gerald's speed? That's what we're finding. What do you get?
1.666666666.
Okay, so where can I put that number in the table?
Beside the 1.
Beside the 1, because in 1 second, he goes 1 point, it's 6 repeating, so type in as many 6s as you can.
That's actually 0.5.
No, it's not.
50 divided by 30. Okay. So then the second part of what Sydney says is divide it out, find that number, and then multiply it through. So then if it's 15 seconds, times that constant of proportionality, but recognize that if it's 0.6 repeating, try to type in a bunch of 6s into your calculator.
But there's a 7.
15 times 1.6666666.
And the end is 7.
No. Sydney? 25. So in your calculators, we're going to go back to talk about this repeating number for a minute. Your calculator ends it at 7. Does anybody know why your calculator puts a 7 at the end? Chris? Because the 6's never end. Obviously, your calculator does, so it just chops it off. And then it just rounds up to the nearest number. So 6 rounds up to 7. But it just stands for 6 repeating. If time doesn't go, how far is he?
Wait, is that, what is that?
0.
Is that 25?
15 times 1.6 repeating. So that's Gerald's speed, 1.6 meters per second. Arnold's going at 1.25 meters per second. So we can see that this number's a little bit bigger, it's a 0. This number's a little bit bigger, so he's moving a little bit faster. Then we're just gonna do the same thing, read Phoebe's situation, fill in her table. Phoebe left the ticket booth at the same time as Arnold, so they're all leaving at the same time. She's also going at a steady pace and arrived at the bumper cars in 20 seconds. So again, that bumper car distance is 50 meters. So right away, I knew that 50 meters took her 20 seconds. So fill in the rest of that table. What's her speed? And then how long does it take her to go 25 meters? How long does it take her to go 0 meters? You're always going to take the number on the right, Parker, and divide it by the number on the left. So if I do 50 meters divided by 20 seconds, what is Phoebe's speed in meters per second? Divide it out. Heather? 2.5. So then where can I put that in my table? Elena? At the 1. That's my constant of proportionality. That's how fast she's moving. If I take 1 second times her rate of 2.5 meters per second. So now I have 25 meters. How many seconds is that? Elena? How'd you get it?
I did 20 divided by 50 and I think I got 0.4 and then I multiplied it by 0.5.
Perfect. So she went a little bit backwards in the table. Not that it's wrong, but she went left to right and then multiplied that through. Exactly correct. We can go that route and get 10. The other route we can go is take that constant of proportionality, 25, divide by 2.5, and we get 10. Either way. So then if she didn't move at all, how much time passed? Go ahead. 0. Okay, so just reviewing how to do your tables. Find your constant of proportionality and either multiply or divide all the way through. The constant of proportionality always shows up at the 1 mark. So if we're looking, person number 1, 1.25 meters per second, 1.6 meters per second, 2.5 meters per second. So who's moving the fastest or who's walking the fastest? Archie.
What's his?
That's 1.6.
Wait, no, what's her name?
Phoebe.
Phoebe.
2.5 meters per second. Okay, I'm gonna switch the slide so we can start looking at their graphs or making their graphs. So that red line was the first graph that we did on Monday. Now we're given the 2 charts that we just filled in and we want to graph them. So what I want you to do is click your color, change your marker to blue.
It starts off blue.
Okay, well then good. So then we're blue and we're gonna graph this first chart. So 0, 0, that's my origin. So we're gonna put that way down here. The next coordinate point is 15, 25. So how do I plot that point? 15 seconds is 25 meters. How do I plot that on a graph? Oh, RJ.
Go by the 15 and then go up to 25.
Over to 15, up to 25, plot your point. We don't need to plot all of the points. If we have 2, go ahead and click on the line tool. Come down to your bottom point or your origin and stretch it all the way up to connect your points. Try to connect it past that point because he doesn't stop moving at 15 seconds. Time continues to move on. We only plotted that first point. Then I want you to switch your color to purple and you're going to plot the second chart. So she has 0, 0. So change back to your pen tool, plot a point at 0. 10 seconds, she moved 25 meters. So come over to 10 seconds, up to 25 meters. And then the same thing, grab your line tool so you can see all 3 graphs. So on the previous screen, RJ said that Phoebe was moving the fastest because her constant of proportionality number was the biggest. How do you see that in these 3 lines? We said that that purple one is the one moving the quickest. How does it show us? It's steeper than all of the rest. We can tell that he's moving slower because it's less steep than the rest. His value is smaller. Are we good? We all have our graphs? I guess I can see it on here. I'm gonna leave you on this slide. Actually, no, I'm not. I'm gonna do this with you because this one's not as easy. So it says Lila left the booth 10 seconds later. Her steady jog enabled her to catch up with him just as he arrived at the bumper cars. Okay, so that sentence tells us that they met at the same time in the same place. So 40 seconds, we have 50 meters. This first sentence though is key to filling out the table. She did not leave at the same time as him. So she let 10 seconds go by. So that means before she even moved, 10 seconds went up on the clock. So instead of starting at 0, 0, 10 seconds went by before she even started moving. It's a 10.
I was gonna say, the 50 divided by 40 is 1.2.
Right, so if we start thinking about that and thinking about constant of proportionality, we would have to do that 50 divided by 40, but we might be hitting a hiccup here because she's not starting at the origin. If my graph doesn't start at that bottom corner point, is it proportional?
No.
So this first sentence, she waited 10 seconds, let him go, and then she started walking. So 10 seconds went by, she's at a distance of 0. So now I'm not too sure how to fill this table in. So scroll down so you can see your graph, and we're gonna plot 2 points. Switch your marker to green. And I wanna plot this first coordinate point. In 10 seconds, she went 0 meters. How do I plot that point of 10, 0? Elena.
Start at the 10 and have a flat do 0.
Right, so I'm at my corner starting point, means move over 10, and I don't move up at all. So it's right down on that bottom axis, my point 10, 0. Next thing, we know that they met at the same time in the same place. So we can plot that coordinate point of 40, 50. So we're gonna go ahead, come all the way over to 40, all the way up to 50. And we have a second point. So now we have 2 points on our graph. I plotted 0, 10 way down here. And then same time, same place, they met up at the bumper cars, 40, 50. Grab your line tool and connect your 2 points.
Like this?
Yep. Because since she did not start at the origin, she waited 10 seconds, I can't use that same pattern of dividing like we were trying to do. You okay?
Couldn't we just like divide it and add 10?
So we can't, because remember, when we were doing scaled copies and stuff, if you add something to everything, it doesn't stay proportional, so we're not allowed to do that, okay? But what we're gonna do now, I connected my 2 points, so now I can see the graph. So if I wanna know how long it took her to go 25 meters, if I look at my graph and come to 25 meters and come all the way, what time is that at? If I make a point at 25 and come down to the time section, how much time passed for 25 meters? What is that number at the very bottom that I'm circling? So I went 25 meters over to my green graph, come down to see how much time went by.
25 to 25.
25. I don't want that line there. Don't do that. So it took 25 seconds. So now it's saying 1 second. So if I come over here and look at 1 second, do I have any green graph over here in the 1?
No.
No, so where is she? What number would I put if it's not, there's not even anything there? Huh?
1.25? No, it's
Did she move at all after 1 second?
0.8.
So let's think about the problem again. She waited 10 seconds before she started moving. So when 1 second went by, did she move at all?
No.
No. So she didn't make any distance. She's way down at 0. So it's a different looking graph. It's a different looking table because she's not walking at that same pattern, starting at the same time and moving. If we look down at this graph, is the graph proportional? The green one that we drew. No, because it's not starting at 0. So I'm starting way over here, so not proportional. I can see the point where they meet up at the same place because those lines are intersecting, but I had to just think about this one a little bit different because she waited that 10 seconds, okay? Are we okay with that graph in that situation? Perfect. So now we're gonna talk about all 4 lines. Purple, blue, red, and green. Which one is moving the fastest and how do we know it? Sydney? Purple line is moving the fastest because it is the steepest. Who's moving the slowest and how do we know it? Purple, well, not purple, we know they're moving faster. Blue, red, green. Elena? Blue? What do we think? So ignore the purple one, we know she's the fastest. So then who's moving the slowest? The blue one, the red one, or the green one? Go ahead. The red one. How do I know it?
Because it's more
The red is moving slower because it is less steep or flatter. Okay, so then we have the constants of proportionality. So we're gonna write them down here just so that we can see them. Our constant of proportionality for the purple line was 2.5. Our constant of proportionality for the blue line was 1.6. The red was 1.25. And the green had none because it wasn't proportional. So I'm just putting those numbers up so that we can see them. Okay, so we talked about how you can see in the graph who's moving faster. How do I know by looking at these numbers that the purple line is moving the quickest? So if I look at all of those constants of proportionality, how do I know if I don't see the graph, I can't see the picture, what about the number tells me that the purple one's moving the fastest? Elena?
Because it has a larger number.
It's the biggest number. Purple, biggest number, moves faster. The quicker you're moving, the bigger your constant of proportionality is, the steeper your line is. How do I know, looking at those, who the slowest one's going to be? Or what about those numbers tell me that red's going to be the slower one? Chris?
The smallest number.
Yep. The red one, smallest number, moves slower. So all that same thing. Slower your constant of proportionality is, slower your rate is, slower you're moving, the flatter your graph. I can't even throw the green one into the mix because it's not proportional, so I can't even compare it to anything else. She's often who knows where, waiting around to go ride the bumper cars. Okay. We good with that? Again, main idea, steeper line faster, less steep slower, bigger number faster, smaller number slower. Can I switch?
Yeah.
Okay, changing faces. Now we have two spaceships. Thank you for the sound effects. I think everyone at home liked it. So they're traveling through the solar system. We have a graph showing each after a given point in time. You have two options down below. Pick which one's moving the fastest.
Well, there's only one that we can see.
What do you mean?
There's only one ship.
Okay, the video, yeah, but the video is just me adding something exciting to look at. The video doesn't have anything to do with the problem. Just look at the graphs. So you have the graphs, you have Perseid 245 and asteroid X. Click which one moving the fastest. And then it's gonna ask you to explain why you picked it. Right? Did it ask you to explain it? Yeah, it does. Because I can see everyone at home typing in their answers. So which one are we picking? RJ, go ahead.
I said asteroid X because it is steeper, so it is going faster.
Okay. Everyone at home is kind of saying the same thing. You guys agree? Right. Another way we can say that is they are going faster. The line is steeper. He went a further distance at the same time. So if we look at the graphs, my time, the time here is the same. So for my first spaceship, I don't know, call this 2 seconds. He only went this shorter distance. My second spaceship at that same time traveled all the way up and went a further distance. So you're measuring time to be the same. He went further, so that means he's moving faster. Okay, so it doesn't always necessarily come from the steepest line. It could depend on how your labels are and what it's asking you to look for. So at the same time, he went a further distance, his line is steeper, he's moving quicker. Okay, one more like this. Graph shows the price of different lengths of two types of rope. So I have a cotton rope and a nylon rope. I buy $1 of each kind of rope. Which one will be longer? So we have to think about the labels. So my bottom axis here is the length. I have L for length. This y-axis is the price, P. So they're asking me if I buy $1. So there's no labels on the X or Y axis, but I can just guess. I'm gonna say that maybe $1 is right here. So if I buy $1 of rope, which one is gonna be longer? The blue or the cotton or the nylon? Elena? How do you know that that one's gonna be longer? Because it's closer over there. So if my price is over here on the y-axis and I come across, I hit cotton first, so that means it's a little bit shorter than whenever I come over here and hit the nylon one. So nylon, because it is further away from the point. So not all graphs are gonna have nice labels and numbers for you to see. You might have to just think and take a second to process what you're looking at. Think about I spelled that wrong.
So you said cotton is steeper.
Right, but we're not talking, like, they're asking us to look at it a little bit backwards. They're asking us to start at the y-axis and go. So even if you think about flipping it, then your other one's gonna be a little bit different.
Nyland.
Mhm.
Is that right?
Okay, last question. I keep hitting the wrong button.
I almost said cotton because it was longer, but once you said P was price, then I said nope.
Yeah, so you just have to pay attention to the labels, just like RJ was saying. He caught himself going in the process of just looking at the steeper line, but you have to think about what it's asking you. What'd you say?
I did that too.
So then this is our last one. It says Noah and Diego left the amusement park ticket booth at the same time. Each moved at a constant speed towards his favorite ride. After 8 seconds, Noah was 17 meters from the ticket booth. Diego was 43 meters away. Which graph is which? So to write your answer, you can just type in like blue and then tell me, can't spell. Blue, tell me whose line is blue, tell me whose line is black. And then explain how you know.
My iPad is not 77. Or was that
I'm putting it to work today.
8. You know, not 88. Wait, yeah, 88, and now it's at 77.
You can make your battery life into a proportional math problem. Drop
Our
1%,
iPad drops.
and then it drops
a lot.
20%, and then 26%. So answer your question. Who's the blue line, who's the black line?
How'd you do
Like
that?
how
You made it go down.
Press enter.
There's no answer for me.
Return.
Return.
Ooh.
So figure out whose line is who, and then tell me how you know. Both of them, you're looking at 8 seconds. Someone is 17 meters, someone is 43 meters. Which one is which? So we're just listing, you're either telling me the blue line is Diego or Noah. Some of you are just writing the numbers, which is fine, but you're just telling me who. So whose graph is who here? I just read through your answers. They're all pretty good. So what do we pick? Sydney?
Actually, so black line is Diego because it's farther away from the
So it's farther away from the end, but we do want to, I hate when, we do want to be a little bit careful. So after 8 seconds. So again, I don't really know where 8 seconds is. I could decide it to be anywhere. So here's 8 seconds. Noah was 17 meters. Diego was 43 meters. So which number's smaller, 17 or 43?
43.
What?
Maybe 17.
17. So that means I hit this number first. I hit the smaller number first. So whose line is the black graph? So who was walking 17 meters in the problem? Read the problem.
Diego's black.
Stay with me. You guys did so good. I don't know what's happening now. 8 seconds. I hit my smaller number first. So who walked 17 meters? Elena. Right. So my black line is Noah, or 17 meters. My blue line is Diego, 43 meters. Okay. Again, not listed down here. I just picked anywhere on that time axis. I know I'm hitting this first. That's my smaller number. So I hit 17 meters, and then I'm going to walk and somewhere up here hit 43 meters. Yeah, Noah, it might be you going to the amusement park. He's talking in the chat. Okay. Make sense? Okay. So there are about less than 10 minutes here. So those of you that are at home can sign out. There are practice problems for today, but the practice problems are in Desmos because there's graphs, and I just think it's easier for you to do them on here than to draw them on paper. So at home, you can get started on that. Check back in 9th period for your attendance. You guys can get started on your practice problems right now, but we're going to work on them when we come back 9th period also.
No, like I was about to.
We can get answer keys.
There should be. Are they not posted?
We also get answer keys for this.
I know, I'm like really nice. Huh?
You still have my thingy? My little paper.
You're gonna do tomorrow, or finish it tomorrow.
Hmm?
You're gonna finish it tomorrow.
Tomorrow.
And then with this homework, as long as you just answer all the questions, it's gonna come through on my end. You don't have to press submit, you don't have to do anything on it.
I'll just see all your information.
There's just a lot of graphs in it. Cool, you guys on the graph paper already at home, this graph paper. So if you're looking at that first one with the matching, the equations, the number in the equation should be that first coordinate point that's plotted. I'm talking about for your homework. So your first coordinate point is 1 comma some number. That is the same number that shows up in the equation.
Ooh.